So we'll continue with the yesterday's problem. So Sidhu has given some of the answers. So మిగతా వాళ్ళు కూడా ఇస్తే బాగుంటుంది. So initially NBS influence of H plus is going to give Br plus. Okay. So Br plus will be added so that it should give more stable carbocation. So here Br will be there and this will be the plus. Okay. So after the formation of carbocation, whatever the alcohol we are taking, okay, that will be going to act like a nucleophile and it will be going to attack on the carbon ion. Okay, so the final product will be this one. Okay, so I expected these products from any one of you, but couldn't get any answers. So try to work out until unless you are going to put your pen on a paper, these answers will not come. Okay. So if you try to remember n number of products, it will be another new question in the examination. So you must practice the way how to write them. Okay. So you must observe the logic. So next, the same Br plus is going to form. Okay. So carbocation will be the intermediate. So and in H2O there will be OH nucleophile, so that will be going to attack, so resulting into what? Orthohydroxy bromo compound. Okay, so this is only given NBS and H plus, no nucleophile is given. Okay, so if that is the case, bromine will be going to add here. Okay, so carbocation will generate here. Okay, now nucleophile will be this one, which will be going to attack. Okay, NGB. Okay, so resulting product will be 1, 2, 3, 4, 5, 5-member ring with methyl and with hydrogen, so it becomes less. And this is the attacking carbon. On the next carbon, it will be bromine. So H plus will be eliminated so that it will form neutral compound which is more stable. So this will be the product. Okay. సో మీరు ట్రై చేస్తే నేను చెప్పినప్పుడు ఈజీ ఉంటుంది, మీరు ట్రై చేయకపోతే నేను చెప్పినప్పుడు కొత్తగా ఉంటుంది. సో ఎన్ని రోజులు కొత్తగా ఉంటే అన్ని రోజులు మీకు అర్థం కాదు, ఎన్ని రోజులు అర్థం కాకపోతే అన్ని రోజులు మాత్రం టాపిక్ ఉండదు. సో ఎవ్రీ టాపిక్ విల్ బి గోయింగ్ టు చేంజ్ ఆర్ విల్ బి గోయింగ్ టు కంప్లీట్ ఇన్ 3-4 days. సో విదిన్ దట్ యూ మస్ట్ గెట్ ట్రైన్. ఓకే, సో నెక్స్ట్ ఇట్స్ గోయింగ్ టు గివ్ carbocation with the addition of bromine. Now this will be going to attack. What is the name of this one? No, this is 2 carbons only. This is not proposed alcohol. So this is proposed alcohol. Okay. So this is acetylene alcohol. Okay. So only 2 carbons are there. So the final product will be this one. Okay. So what if allyl alcohol is treated? The same thing is going to happen. That in presence of acetylene alcohol, it will be allyl alcohol going to attack. Okay. If this proposed alcohol, the same proposed alcohol. Okay. So these are the examples which I given. So if you want to write, you can write, or if you want to take the screenshot, you can also take. Okay. So today we're going to see the stereochemistry of electrophilic addition reagents. Okay. So if you take different reagents, for example H2, and for example halogen, and you have taken hydrohalogen, okay, hydrohalogenation, HCl, HBr. సో హెచ్బిఆర్ తీసుకున్నప్పుడే అడిషన్ ఏమైంది, యాంటీ అడిషన్ అయింది. ఓకే, యాంటీ అడిషన్ విచ్ మీన్స్ one will be at one side, other will be opposite, which is 180 degrees. Okay, so the same thing you have observed in Br2. Okay, Br2, so there is also anti-addition. Okay, so stereochemistry is that only. Okay, so addition of reagent with their spatial relationships. Okay, so if it is completely 180 degrees, that will be anti-addition. Okay, so generally hydrogenation in presence of metal surface, palladium, platinum. So that hydrogenation will be on the metal surface. Okay, initially olefin is going to attach to the metal. Okay, so it is going to form metal attached to olefin. Next, sorry, initially hydrogen will be going to attach to the metal. Okay, so resulting hydrogen absorbed metal. Okay, so when olefin approaches, so it's going to take the hydrogen, resulting into the product. So as the metal surface is allowing the hydrogen molecule from the same side, so this addition will also be same. Okay, so if a electrophilic addition in terms of metal or hydrogenation, that will be same side addition, we will call them syn addition. Okay, syn addition. If it is 180 degrees, this is called anti addition. Okay, so generally homodiatomic molecule except halogens. Okay, this is halogen. Halogens will be anti addition. Otherwise homodiatomic molecule H2, deuterium, D2 will give syn addition. Okay, heterodiatomic molecules. Okay, for example HX, HCN, HOH, that is what, H2O. Okay, so hetero molecules will give anti addition. Okay, so with this what will how we will apply means, if I take 2 butane, okay, 2 butane, and I have treated with H2 with platinum or palladium. So how it is going to happen? The hydrogen will attach from the same side. Okay, hydrogen will attach from the same side. So you must keep the hydrogen same side and methyls with opposite side. So what it is going to give? Syn addition. That's why it is given cis product. Okay. So on this basis of addition types, you will be going to give the products. Okay. So how the products will be going to form. Okay. Is it clear? Is it clear or shall I repeat? Am I audible? వినిపిస్తుందా? Okay. So we'll see the complete reagent types. So which are with anti-addition HOX. Okay. For example, HOCl, HOBr. Okay. These are also anti-addition, and para acids. So we will call it as RCO3H followed by the H2O. They are also anti-addition. Okay. So then what are syn type? So generally syn type will be osmium tetroxide. Okay, so when a olefin is treated with osmium tetroxide, it's going to give cis diol. Okay, so two OH groups will attach from the same side. Okay, cis diol. Okay, next KMNO4 followed by H2O. So this is called if it is cold dilute system, so this is called Bayer's reagent. Okay, so when a olefin is treated with Bayer's reagent, it's going to give cis diol. Okay, so these two are same. Okay, so these are the syn attacking species. Okay, what so hydrogenation in presence of metal surface, osmium tetroxide and KMNO4 followed by the water. Okay, so they are going to give syn addition. Okay, so rest all halogenation, hydrohalogenation and other hydration, heterodiatomic molecules, they will give anti addition. Okay, so write down, take the screenshot. So we are going to follow up the reactions based on these stereochemical conditions. Okay, I think there might be some technical issues or network issues, so if anything is there, please follow on the YouTube. Okay, so is it clear? So if you want repetition, okay, so now write the questions. So here I taken 2 butane and treated with HCl. So what could be the product? And the same H2 by platinum. What could be the product? Product? Okay. So there was some issue. So YouTube లో ఇప్పటి వరకు షేర్ కాలే, ఇప్పటి నుంచి అవుతుంది. Okay. Hmm. Any answers? So this is what HCl, which is going to give anti-addition. Okay. So one should be from this side, one should be from this side. Okay. So that these one of the double bond will eliminated, and what should be there? These should be trans. Okay. So keep them trans. Okay. And rest become methyls or whatever the substance. So what you got? You got a trans product because it is anti-addition. Okay. If the same is treated, okay, if the same is treated with hydrogenation, this is syn addition. Okay. So double bond become triple bond become double bond, and you must add two hydrogens to the same set. So the other substituent will be uh, on the other positions which are left. Okay, so what is this? This is cis product. Okay, so based on their addition types or stereochemistry, you must define the products. Okay, is it clear? Addition nature ni sin అంటున్నాం. Okay, so when two groups are same, then we consider them as cis. Okay, when two sides are same, for example, if the two, let's say here I am taking two groups which are different, but their position relevance is said to be syn. Okay, same side, syn means same side. If it is same groups are present, then we will call them cis. Okay, it is a cis product. It's a product nature, it's a spatial relationship. Okay, so side nature. Okay, సేమ్ సైడ్ ఉన్నాయని చెప్పడానికి సిన్ అని చెప్తాం. ఓకే, ఒక ప్రోడక్ట్లో రెండు గ్రూపులు సేమ్ ఉంటే, సేమ్ సేమ్ ఉండి సేమ్ సైడ్ ఉంటే అవి సిస్ అంటాం. ఓకే, ఆల్మోస్ట్ దే ఆర్ సేమ్, బట్ అడిషన్ విల్ డిఫైన్ విత్ సిన్ అడిషన్. ఓకే, సో దీస్ ఆర్ అడిషన్ టైప్స్, దీస్ ఆర్ ప్రొడక్ట్ టైప్స్. ఓకే. So now try to write the other examples. So cyclohexane I have taken and treated with H2 influence of palladium, and one more osmium tetroxide with H2O, and KMnO4 influence of H2O. So this is Bayer's reagent, cold dilute alkaline KMnO4. So what could be the products? Try to write fast. So what is the answer? So if it is hydrogenation, is it syn addition or anti-addition? So if it is syn addition, it must add to the same side. So write the hydrogens to the same side. So cis product. Okay. Anyhow, trans product is not possible. If at all possible, it must be twisted product. Okay. Double bond ki twist ayi untadi. So అది difficult అయితది. So if they ask me on tetraxide, is it syn addition or anti? Syn. So two OH groups are going to add to the same side. So diols, syn diols will form. Syn diols or cis diols will form. Okay. So if it is Bayes reagent also, it's going to give the same product. Okay. So write the products. Add some more examples. To butane with yeah. Okay. Okay. Hydrogen in gaseous. Yeah. So when metal is taken, it's not a huge part of metal. Okay. మనకు కనబడేలాగా ఐరన్ రాడ్ అటువంటి మెటల్ తీసుకోమన్నట్టు. ఓకే. సో ద మెటల్ we will take metal powder. Okay. Which has large surface area. Okay. So nanoparticles, nano powder. Okay. So we'll take that powder. Okay. And on that powder we will absorb the hydrogen with high pressure gas. Okay. With high pressure gas we will absorb the metal uh, hydrogen onto the metal surface. Okay. So based on the absorption. So for better absorption we will also use metal based charcoal. Okay. So because charcoal has a larger surface area. So this charcoal is dissolved in the reaction system. Okay. Which is liquid. Now it will be the reagent or, and again we'll keep the hydrogen with the balloons or with the high pressure containers. So hydrogen will come and absorb on the metal surface, and that metal surface is going to react with the liquid compound. Okay. So finally you're going to get the product. So this is what the physical existence or physical appearance of the reaction. Okay. So here I am taking some other examples. 2-butane with bromine. So what could be the product? And HBr and Br2 in CCl4. HOCl. So write these products and submit in the group. So you should submit the responses so that I can understand how extent you are going to comfortable with these topics. Okay. So try to share your responses. Okay. So take the screenshot and write the responses. So next, so if a double bond product is there, for example, here I am taking cis butene. Okay, so earlier we have taken triple bond and now we are taking cis butene. Okay, double bonded, and if it is treated with bromine or in presence of hydrogen. Okay, so what could be the products? So there will be a products like this, two types. So if any compound, if the groups like this, let's say here bromine is also there, if the same sided groups are there and it is sp3 carbon, okay, if it is sp2 carbon, double bonded carbon, we will define them as cis and trans. Okay, so if it is sp3 carbon and if the two are same side syn, okay, same side, then it is said to be erythro product. Okay, erythro product. If the two groups are opposite to each other, okay, anti to each other, then that is said to be trio product. Okay, trio product. So this is erythro isomer, this is trio isomer. Okay, so if the two groups are anti, then it is trio. If the two groups are same side, it is erythro. Okay, so with these kind of additions, you will get either trio or erythro products. Okay, if the erythro product having plane of symmetry, okay, if the erythro product having plane of symmetry means which can dividable into two equal halves by passing a plane between the two groups, then it is also called as a meso product. Okay, meso isomer or meso product. Okay, if not, if it is having two chiral centers and the molecule is also not having any plane of symmetry, then that is said to be active isomer. Okay, active isomer. Is it clear? So stereochemistry is also a little bit involving in this. So try to hold the names. If the same sides are, of the groups are present in sp3 carbon or around the chiral centers. Chiral center means which are having four different groups. For example, if I take this as a chiral center, it is having hydrogen attached, methyl, OH, and the complete group. Four different groups are attached, so that is said to be chiral center. Okay, so if the chiral centers are present and two groups are same side, then this is said to be meso product. Okay, only two chiral centers. Okay, if the two groups are opposite side, then it is anti-product or trio product. Okay, or erythro product. This one, meso is erythro. If it is having plane of symmetry, it is meso. If not, you can directly call as erythro isomer. Okay. So if it is bromine is, let's say this will be simpler. So if it is hydrogen is attaching, so these two groups are already same side. So if the hydrogen is attaching, it will be going to attach from the same side. So here I write, so two methyls on the same side, okay, and two hydrogens already on same side. So hydrogen which is attaching will also be same side. So it is going to give the erythro type product, okay. So but not having chiral center because it is two groups are same side, okay. So if it is bromine, they must attach opposite to each other because their addition is anti. So methyls are same side, but whatever the groups hydrogen become reverse. Okay. So if this is the case, so bromine why it should attack here? It can also be possible to attack here, but it should be 180 degrees must be there. So these are the two products. Okay, which are not erythro, which are trio type. Okay, trio isomers. So which are not having plane of symmetry, so they are active isomers. Okay, so the optically active, it means active means optically active. optical activity, here I give brief introduction about the optical activity. So when you pass a light, okay, when you pass a light through a transparent material, so it will refract and it will reflect, okay, and it will transfer also, okay, transmit. So these are three phenomena, okay. If I keep this material in a flat position, but if I place a material in curved position, so what's going to happen? So it will deviate with different angles, isn't it? So this is called refraction, or angle of deviation will be different with the incident light, okay, incident light angle whatever may be there, it will be going to change, okay, because it is non-planar, okay, so non-symmetrical. If the material what it is reflected is non-planar, so that's going to give this kind of angle of deviations, okay. So the same thing if the molecule is also present which is not symmetrical, and you are passing through that molecules, the light, incident light, if it is passing through this kind of molecules, it will refract or it will change the angle of incidence, okay. So we will take a plain polarizer light, okay, we will take a plain polarizer light, okay. So I will show that also, how the optical activity and polarization will happen. So the first picture is a polarimeter advanced. So this is a primitive polarimeter, okay. So this is advanced and this is the principal. So I hope you are able to see this, okay. So this is what polarimeter setup. So we are passing a light, okay. So we are passing light from here, okay. So light will be in different angles, but we'll make it into one angle or one plane, that is called a plane polarizer light, okay. So its plane will be one. So until unless molecules are not symmetric, molecules are curved, okay. So if the molecules are curved, this angle will be going to bend, okay, this angle will be going to bend. Otherwise angle will be the same, okay, when it is transparent or without any uh, curved molecules, okay. So these curved molecules are said to be optically active molecules because they are not planar molecules, okay, they are not symmetric molecules, okay. So when we are observing the rotation of the plane polarizer light, then it is said to be optically active, okay, because they are active towards the optical lights, okay. So they are said to be optically active compounds. So it is not possible with physical experiment. So we with many compounds, okay. సో అన్ని కాంపౌండ్స్ తీసుకొని ఆప్టికల్ యాక్టివా కాదా అనేది మనము పొలారిమీటర్లో పెట్టి చెక్ చేయడం టైం కన్జ్యూమబుల్, ఓకే, అండ్ డిఫికల్టీ ఆల్సో, ఓకే. సో దట్ వీ విల్ define a criteria with chemical nature of the molecules with the structure. So if they are non-symmetric, okay, non-symmetric means if they are not planar, okay. So if they are not similar from different sides, okay, I mean if it is different from the different angles, okay. So whatever may be the light incident angle, so it will be going to rotate. Okay, సో మాలిక్యూల్ అన్ని దిక్కుల నుంచి ఒకలాగా ఉంటాయి. ఏవన్నా రెండు సైడ్ల నుంచి లైట్ పడింది అనుకోండి, సో అప్పుడు యాంగిల్ చేంజ్ అనేది సేమ్ అవుతుంది. కానీ అన్ని దిక్కుల నుంచి డిఫరెంట్గా ఉంటే ఏ యాంగిల్ నుంచి పడినా కానీ మనకి ప్లేన్ పోలరైజ్డ్ లైట్ అనేది రొటేట్ అవుతుంది. ఓకే, సో రొటేట్ అయితే దాన్ని ఆప్టికల్లీ యాక్టివ్ అంటాం. ఎప్పుడు రొటేట్ అవుతుంది? ఎప్పుడైతే మాలిక్యూల్ అన్ని యాంగిల్స్ నుంచి డిఫరెంట్గా ఉంటుందో, దట్ ఈస్ సెట్ టు బి నాన్ సిమ్మెట్రిక్. ఓకే, so if it is symmetric means it must be having plane of symmetry or it must be having axis of symmetry. Okay, so axis of symmetry means if I take a triangle system. Okay, if I take a triangular planar system and if I am keeping an axis through the middle and rotating, I can see this same visibility. Okay, this flat area visibility three times. Okay, through the rotation, so it is three times similar with the axis. Okay, so if this is also there, then it is also non it is also non optically active. So if it is not symmetric, then it is optically active. Okay, so symmetry can be observed for chemical compounds with the chiral center. If a chiral center is present, means it must have four different groups. Okay, four different groups around the carbon. If that is the case, that center is optically active or that center is chiral. Okay, so there may be a chance of optically activity. Okay, సో మాలిక్యూల్ మొత్తం నాన్ ప్లేనార్ అయి ఉంటే ఆప్టికల్లీ యాక్టివ్ అయి ఉంటుంది. ఓకే, సో అటువంటి కాంపౌండ్స్ని యాక్టివ్ కాంపౌండ్స్ అంటారు. ఏవైతే ఆప్టికల్ యాక్టివిటీ ఉండదో, ప్లేన్ ఆఫ్ సిమెట్రీ ఉంటుందో వాటిని మీజో కాంపౌండ్స్ అంటారు. ఓకే, సో in stereochemistry we will be going to discuss in detail all this. Okay, so but right now you need to note the names. Okay, so if erythroisomer having plane of symmetry, that is said to be meso. If it is not having plane of symmetry, that is said to be optically active. Okay, so two optically active compounds. So here you're going to get two optically active compounds. Okay, so which are mirror images of each other. Okay, if you see, so this is exactly mirror image to this compound. Okay, the two optically active compounds which are mirror image to each other are said to be enantiomers. Okay, enantiomers. Two optically active which are mirror image to each other are said to be enantiomers. If the mixture of enantiomer is there, okay, if the mixture of enantiomer is there, then that is said to be racemic mixture. Okay, racemic mixture. Why it is said to be racemic mixture means, so enantiomer, if one is there, this is going to rotate, let's say it is plus 60 degrees. Okay, that incident angle will be rotated with plus 60 degrees. The exactly opposite will be rotated by the another enantiomer. Okay, because they are mirror images, they are one and the same but opposites. Okay, so if I mix these two, it will be 0 degrees. Okay, so this kind of mixture is said to be racemic mixture. Okay, always racemic mixture angle or optical activity will be 0. Okay, so either if it is going to give racemic mixture or it is going to give meso product. Okay, when a double bond is treated with electrophilic addition reagents. Okay, so we'll see the example. So far what I given is the terms of the products. Okay, so hope you will catch all the terms: enantiomers, racemic mixture, meso product. Okay, optical activity, stereoisomer, erythroisomer. Okay, so these are very useful terms. Okay, for further stereochemical relationship and further examples also. Okay, so if any doubt, ask, I will repeat. So which are non-mirror images. Okay, which are non-mirror images, stereoisomers are there, then they are said to be diastereomers, which may be optically active, may not be optically active. For example, if you take the meso product and the one of the racemic mixture product, okay, and non-sugar, so this one BR H BR H CH3, this is BR H. So will there be a mirror images? So, but they are isomers because they are having same molecular composition, molecular formula. Okay. So stereoisomers. Okay. Stereoisomers means isomers which are having same formula and same bond connectivity. Okay, same formula, same bond connectivity, but spatial arrangement is different. Okay, if the spatial arrangement is different, it is about the stereoisomerism. Okay, stereoisomers which are non-mirror images are said to be diastereomers. Okay, which may be optically active, this is optically active, may not be optically active, this is meso, this is non-optically active because it is having plane of symmetry. Okay, anything else? Okay, so let's move. So here I am taking the trans 2-butene, okay, and treated with bromine. So what could be the product? At the same time, treated with hydrogen and platinum, treated with osmium tetroxide in terms of H2O. Okay, so how to write the product? So this is what trans. Okay, and its addition, bromine addition, will it be syn or anti? Anti. So trans and anti combination will give meso product. Okay. So because it is opposite. Okay. And the attacking will also be opposite. Okay. So hydrogens will be this. So if I make all are anti. Okay. All are anti. If I rotate this to the 180 degrees, so all become same side. Okay, CH3 CH3 same side, hydrogen hydrogen same side, Br same side. So you can remember trans and anti addition, trans compound with anti addition will be going to give meso. Okay, the same trans compound, so hydrogenation, is it syn addition or anti addition? Syn. So trans plus syn addition, it will be going to give racemic product. Okay, racemic mixture. So what is racemic mixture? So two combinations of three of products. So Br, sorry, here H and H. So here also H and H, CH3, CH3. So if I write hydrogen this side, if I write hydrogen this side, it is one and the same. Okay. So if it is optically active, you need to write another product also like this. For example, if I take 2,3-dibromo trans 2-butene and treated with hydrogenation. So this is an trans product. This is in addition. Okay. So two combinations of trio. So one bromine will be this side. So addition must be same side. Okay. So like this. So if I place the two hydrogen same side, molecule will become anti, these two will become anti. Okay, so if I rotate the methyls on same side, the molecule will become reverse. So hydrogen will get opposite side. Okay, so second carbon bromine is right side here. The same can be reversed. Second carbon bromine can be, so two mirror images. Okay, so this is called a racemic mixture because this is not having planar symmetry, optically active, which can be reflected on each other. Okay, reflected on each other. Okay, so if I take osmium tetroxide, this will be going to give again a racemic mixture because it is syn addition. So trans with syn, it is racemic mixture. So OH, OH. So CH3, CH3, and hydrogen, hydrogen. Okay. So conclusion is what? If it is a trans and anti, it is meso. Trans and syn, it is racemic. Okay. Same if it is cis plus syn, same. Okay, same side. So again it will be going to give meso because these are opposite will give meso. Okay, so again cis and anti, it will be going to give racemic. So these are the conclusions. Based on that, you need to work out and write the products. Is it clear? So try to write these conclusions first. Then we will be going to see some more examples. ఆ రెండు ఎనాన్షియోమర్లు కలిస్తేనే రెస్మిక్ మిక్చర్. ఓకే, it is the combination of two enantiomers. Okay, so that is what racemic mixture. If it is one enantiomer, that will be only enantiomer, pure enantiomer. Okay, no. Next, try to write the products for with Br2 in CCl4 and osmium tetroxide. So something is going to happen. So write these examples and submit in the WhatsApp. Okay, so I will try to make some more videos after this disturbance. Okay, thank you.